Hello grade 12s, welcome to my channel. And somebody who wrote, I believe this is the IEB paper written this year, hopefully, asked me to have a look at these questions. Of course, they said they wrote so well, but they needed a bit of a check on this one. So if you wrote this paper and you probably are interested in knowing what were the approaches or strategies that you could have used to answer question 11. Now here comes the strategies. So let's have a look at this paper quickly and see how it went. So we are told in the diagram below, the equation of the circle with center C is x squared plus y squared minus 12x minus 4y plus p equal to 0. So this is an expanded form of the equation. So this form does not make sense usually. So the best thing is to complete the square and express it better. So the best way is to take what is under the square, take the sign between the x terms, half the coefficient of x, and then square that thing. That's the first part. So you need to know how to do this quickly, guys. No need for no long methods here. This is grade 12. We're applying knowledge. We're not really testing the semantics of it. Now let's go. Take what is under the square for the y. Then we follow the sign between the y terms as negative. Half of the coefficient of y is 2. And then we square that. We move along. We take p to this side. Obviously, we're going to add a square of this number right there. That would be 36. Plus a square on this number right there. 2 squared is a 4. Alright, so that is what we have. Okay, so we can simplify further. We've got x minus 6 all squared plus y minus 2 all squared equals minus p plus 40. So this is our equation of the circle. So this is the most useful format we can imagine. Okay, AO, OB, and AB are tangents to the circle. So let's have a look. We can see that definitely these are touching the circle. So essentially, that is what we are having here. All right, so we're told point B is 12 and 0. So it's a point on the on the x-axis. Okay, let's get another color so that we can do some justice to this diagram. Obviously, what are we looking for, guys? If this is a tangent, it means a line from center to the point of tangency. The tangent will meet that line at right angles, right? Right. And likewise, this is going to be the same scenario, meaning this line should be perpendicular to the tangent because the tangent is always perpendicular to radius. Same story for that other point over there. That point of tangency also should be at 90 degrees. Great. So we have that, not a problem. So what do we do now? Well, we need the center of the circle. Now, the center can be drawn from what we have above. So we know that the center C, take the opposite sign of that term, that constant inside the bracket. So it's going to be 6. And this one, we take the opposite as well. It's going to be 2. So this is our center. So we can see that, center C is basically 6 and 2. All right, so that is important. So if this is the case, can you see this is 12? Now we have 6 right here. Maybe let's call this point of tangency P. Now, if this line is perpendicular to the x-axis, it means this line is also parallel to the y-axis. And if this line is parallel to the y-axis, it means the x value at this point will be the same as the x value at C. So we're going to have 6 but 0 on the y, because this is the line y equal to 0. Okay, so this is essentially what we can do at this point. Maybe we can call that one point Q. Okay, this is some x value and some y value, which we don't know. We can call that one point R. This will also have some x value and some y value, so we don't know those ones at this point. Not a problem. So what can we do? We also know that this line right here is also equal to that line, also equal to that line. Why? These are radii or radii. Okay, that's good. But what do we know also? We also know that tangents from the same point outside the circle to the same circle, they should be equal from that point to their points of tangency. So this already creates for us a structure that says we have a kite here. All right, that's what we can say. Again, point A is a bit of a situation. We don't know for sure what those coordinates would be. So this is essentially as far as we can go with analyzing this diagram. So let's see. We can't seem to be doing much here. We really don't seem to be doing much, so we just have to find out from the questions. It says determine the value of P. Okay, so P, do you realize, folks, that essentially this distance right here, do you realize that this distance from center to circumference is the radius? But this is a vertical line, meaning the the y coordinate at our point C is effectively the distance. This is 2 units. Okay, so can you see our radius is being given indirectly? So there's so much we can learn from this. So the radius is 2 units. Obviously, you wouldn't know from there, but we can see that the radius is essentially 2 units. So, but from what we could tell here, we can say the radius is equal to the square root of minus p plus 40. But we can tell now that actually it comes out as 2. Alright, so guys, these are questions that need you to take your time a little and first understand your diagram as best as possible, because these are higher order questions or higher grade questions where they give you not so much, but you have to realize the rest by yourself by being analytical and also integrate all the information you have learned somewhere. Okay, now let's move on. What do we have? Well, what we've got, we need to find the value of P. So it's obvious now that we have found that the radius is 2 units. It means this situation here is going to be equal to 2 squared. And we can be able to solve for P. Obviously, to answer this question, we need to write our equation in that format first. All right, so let's answer this question A. Okay, so A, we're going to answer it like this. From what we have, we can say the equation of the circle C is given by x minus 6 all squared plus y minus 2 all squared equals minus p plus 40. You don't need to explain too much because at times it gets overwhelming. All right, so we can say therefore the center C is going to be 6 is to 2, and the radius is going to be equal to the square root of minus p plus 40, because it would be the square root of this. All right. Okay. All right. Now, what do we need to say now? We can say since OB is a tangent to circle C on the x-axis, okay, it is such that we can see that now. It is such that what can we say? Okay, let's call it that this is at point P, ne? Because you will have chosen to write point P there. Sometimes you don't have to explain too much. So since OB is a tangent to circle C on the x-axis at P, it is such that OP is perpendicular to OB. No, not OP, but CP. CP is perpendicular to OB. Why? The tangent is always perpendicular to radius. Okay. We can say also, therefore, the radius of circle C is equal to 2 units. Okay. Of course, someone can tell what is going on here. You will have indicated some of the things. Sometimes the explanations get a little bit boring and you don't want to end up writing a very long essay. You just want to say enough and show enough. I mean, if we're saying this is perpendicular to the x-axis, it also means this line is parallel to the y-axis. We can say also CP must be parallel to the y-axis. Okay, so that is the essence of this question. So that is a perpendicular line. The radius is going to be units. So sometimes stop there, don't go far. Now what do we need? We can say then, what do we know? We know for a fact that minus p plus 40 is equal to 2 squared, because that would be the radius squared. Then we continue and say this implies that minus p is equal to 4 minus 40, right? Which also implies that minus p is equal to minus 36. Therefore, when you multiply by negative p is going to be 36. All right, that's it. It's a bit of a math essay if you think about it, but of course in maths you have to show your workings, because if you don't, you are going to see flames. So what is important here, I don't know how many marks were allocated here, but obviously writing this equation in the standard format should be a mark. Milking out that the center would be that is important, and also the radius is important. Now this story here is just a justification for this eventually. So maybe that would be the 4th mark and essentially the answer, because the rest is just a simple mathematical relationship. At best, we would get 5 marks here. Maybe if they wanted to give you more, they can give you essentially 6 marks, probably for these 2 reasons. I'm not too sure. But I would leave it at 5 marks in the meantime. Probably more, I don't know. This question paper wasn't given to me complete. so I cannot be too sure. All right, let's look at the next question. Next question says, determine the equation of AB and show all your working. Okay, so as you can see here, we've worked on our diagram a little bit, so we want the equation of this line. So we've got this point B, all right, but now we've got a lot of points we don't know on AB. We don't know point Q, we don't know point A. All we know is that this line is perpendicular to Q, but we also are not able to find the gradient of this line. So yes, we could use simultaneous equations. Say this line is equal to that, those are ready. Then we use this point to find the first equation. But now what would be the second equation? The second equation would be when we say this line from P to B is equal to the line Q to B, y tangents from the same point. Then we get a second equation, and from that probably, but it's going to be a bit hectic, we can at least attempt to find the coordinates of Q. So our challenge here is finding the coordinates of Q. Okay, so you can see we can use simultaneous equations. We draw simultaneous equations based on the radii from point Q to C and point C to P, and also drawing equal distances from Q to B and from P to B, all right, because we know that point P, at least we have found the coordinates. But yeah, that looks a bit hectic. Now, I allow a little bit of creativity to kick in, because if you don't understand maths, this is what shows that you actually don't. So for me, I would say, what if I cut this thing like that? Maybe let's try and show it a bit better. All right, if I cut my lovely circle like that, I mean my what do you call that structure? If I cut it like that, remember I decided this is a kite, ne? And if it is a kite, I know that the longest diagonal of the kite cuts those angles into two, or it bisects those angles, right? They themselves are not equal, the opposite angles, that angle and this one, but it cuts them into two equal angles. So I don't know, should I put a star there maybe? So all we know is that those angles are bisected by the longest diameter of the kite. Now this tells me that here I have a right-angled triangle, right, which I can use to my advantage. Why? Because I know I can calculate this angle. If I calculate this angle, I essentially have this angle. All right? And having that angle means I can be able to determine the angle of inclination of this line. From that angle of inclination, I can find the gradient of this line. And from that gradient of this line, that means I can just substitute this point to the standard format, and I've got my answer. Because essentially these triangles are congruent. If I find this angle, I've already found the other angle. So that is the story. So these ones need you to understand a bit of maths to move around. Okay, so I can say here essentially, to answer my B, I'll start by naming the two equal parts. I can say CP is equal to CQ, as you can see on my diagram. Just say CP is equal to CQ. Why? These are the radii, okay, or radii. And then I can say also, I know that PB is equal to QB. Why? These are tangents from same point outside the circle. So it tells me that therefore this structure PCQB is a kite. Okay, now that is important. Again, why the two pairs of adjacent sides are equal. Okay, we can just say two pairs of adjacent sides are equal. So that becomes a kite. Okay, all right, okay. So if this is a kite, we can say then draw CB. Now this one is a construction, so this is our creativity trying to kick in here. Maybe let me write a bit more clearly. I know sometimes my writing is not the best, but we can say then draw CB. Ne? We're not distorting the diagram, we're just constructing CB. Why are we doing that? Because we can see here that essentially this is the stuary, this is the stuary, this is the stuary. So we can just simply say, okay, such that we can see now that essentially point P is 6 and 0. Did I ever mention that elsewhere? I did not, so I have to mention that. So why is it that I know that essentially CP is a vertical line? Okay, maybe I'm giving too much reasons, but I have to. So I'm saying CP is a vertical line. Okay, obviously the tangent meets the radius at right angles, so those are some of the things that we mentioned. I don't know if we ever mentioned it. Yes, we did mention it, so it makes life a lot easier. But we need to state those coordinates. Okay, so this is going to take us somewhere. Now we're going to say here, in, or maybe let's not even say that. We don't even need to state a lot of things. We can say we want PB. Okay, let's just do it nice and easy. We can just simply say sine, because we're interested in the angle. Is it sine or tan? We need tan, because we just want the sides that we have. This is 2 units, this is going to be 6 units. So we can just simply say tan. Now we're applying trigonometry a little bit. So we can say tan of what angle D? Sorry for the back and forth. This is CBP. Let's just call it that way. CBP is equal to the opposite side, which is CP. Just state those sides. It's going to be CP over PB. Obviously, this one doesn't need to be justified. 10 is just 10. So we're interested in the angle, actually. That's why we're doing all of this. CP is 2 units. Over this one, we needed to determine this, but I'm going to complex it here. It's basically going to be 12 minus 6, because that is essentially a horizontal line. So I'm just showing that this would have been a separate calculation, but I'm not interested in writing a lot. So what do we have here? This is 2 over 6, which is 1 over 3. Right. So therefore, we can say, therefore, CBP is going to be the shift 10 shift 10 of a third. Obviously, this is not going to give us the true angle, because remember, this angle is on the inside. So we need to find the angle on the outside, which is the true angle of inclination. Okay, so yeah, I'm actually tempted to write a negative angle here, because for me, if I put a negative here, it literally will give me that obtuse angle. You know that? Let me just see. But of course, let's just not be silly. Let's just follow the steps properly. So what would be that angle? Because we're not done. Actually, I'm rushing, so I'm not done. So this is shift 10 of a third. So it is 18,435. This is 18,435 degrees. Now this is the angle. But can you see, we did not write so much as yet, but yeah, we're going far. So this is what we have. So we've got that angle, but we want the whole angle. So this is going to be a very silly situation, I'm telling you. So we can say here, but we know that CBP is equal to ABC. ABC. Okay, why? You can just say the longer tangent, the longer diameter. These are corollaries. The longer diameter of a kite bisects the opposite angles. So essentially it bisects this angle here, PBA, as well as QCP, although they are not equal, but it bisects them. So yeah, it's a lot. Okay, so what does this imply? This implies that this angle ABP is going to be equal to 2 times 18,435 degrees, which is going to be 2 into 18,435. I'm just not rounding off too soon, so this gives me a 36,87 degrees. We're not done, Bafwet. We're not done. We can say therefore. Now, what is the angle we're trying to get to? We're trying to get to ABX. Okay. So this means angle ABX is going to be equal to 180 degrees minus 36,87 degrees. Why are we saying that? These are angles on a straight line. So this question was not easy. This was a suplex city in analytical geometry. Okay, so let's do it. 180 minus 36,87. It gives us a 143,7 13 degrees. Now that we have that angle, we can simply say then we know that the gradient of AB is going to be equal to the tan of ABX. All right, that's its angle of inclination. So this is the tan of 143,13 degrees. So let's just say tan of 143,13. So this gives us A minus 0,75. Okay. Yeah, essentially, even if you round off to 2 decimal places, that's what we get. So 0,75, what is that? 0,75 is basically 3/4. Ne? So which it's best if we write it as minus 3/4. Do you know how to convert decimals to fractions? You just transpose this back. It's going to be 75. But you moved 2, so you divide by 100. And then you ask yourself, what is common to 175? It's 15. No? Is it 25? I think it's 25. Yeah, 25 to 75 goes 3 times. 200 goes 4 times. So you need to be able to do these kind of things, guys. Sometimes your calculators are spoiling you because they make life easy for you. But anyway, that's fine. We can say, therefore, line AB is such that y is equal to minus 3/4 x plus c, which now means through point B, which is 12 and 0. We know that 12 is going to be equal to minus 3/4 into 12. Actually, I'm substituting incorrectly here. This should be 0 plus c. And therefore our c is, now this 12 divided by 4, that's 3. 3 by 3 is minus 9. 9 to the other side is just 9. Okay, so that's it. So we can say, therefore our equation for AB is essentially minus 3/4 x plus 9. That is the equation of the line. So at least we've got a negative gradient, and essentially it will have a positive y-intercept. So for me, it could be an issue of the numbers, which sometimes mistakes do occur when you have an essay type of question like this, because these are questions that are just naughty. Naughty. You can see here, scoring a lot of marks by integrating topics and knowing what you need, moving from one point to the next, and of course attempting to explain your way as you move along. I don't know how many marks this is, but obviously this should be an important step, right? And getting this gradient should be an important step, and essentially working out this angle is also an important step. 1, 2, 3. 4. Yani 4. 5. I think 6. 6. I think 6 marks. Maybe we can make it 7 marks, because I do believe what we need is a little bit more, maybe 7 marks. But I'm just trying to find a place for this mark to be. But I think the critical step was also knowing this, perhaps somehow. Yeah, maybe let's say 7 marks at best, but it could easily be an 8-mark question. It's a very silly question, I'm telling you. So instead of giving you those little short questions that are just going to drive you to some 22 marks, this one could be scored in just those 2 questions. As you could see, there is a lot you needed to say, and they are all not necessarily going to be less than 5 marks each. So that is essentially how this question could be attempted. All right. So since we're already here, let's just keep going and not waste any more time. Yeah, that was a suplex city. A lot needed to be said, and we needed to perform quite a few gymnastics there. Okay, let's get to this question 9. Question 9 is just the trigonometry section. Of course, I guess my student here felt, this probably was a bit of a problem. So let's have a look. Simplify the following into an expression containing only one trigonometric ratio of theta. Okay, this is easy. So I'm not going to rewrite this. So I've just gotten a half here. Now cos of 90 plus. So once you see 90, you know that we're going to use the co-function for cos. But now cos in the second quadrant is negative. So this means the co-function should follow the sign of the original, and co-function of cos is sine theta. So we are using reduction formulae. So we're using what we call the 3-step approach. Of course, it's not anything fancy, guys. It's just me being naughty. So here, the first step is BODMAS. Okay? BODMAS as in algebra or arithmetic, meaning directly, but it can also be applied to trigonometry. For example, brackets of could mean reduction formulae, and essentially any other brackets, because reduction formulae, you've got brackets that you want to break. Okay? And then DM applied here, you can just talk about dividing common factors, dividing by common factors. And maybe let's just say dividing common factors. And then of course this could easily just mean simple multiplication and division. And then this AS portion could easily mean dealing with special angles. Okay? Or just simply doing like terms as it is. So this could be very, very useful. So please be aware of the applications of this thing. Okay? It's a very, very, very nice thing. Special angles or just BODMAS as you know it. The second stage of this, you can use factorization. Now factorization has 3 formats. The highest common factor. We can do the difference of 2 squares called dots. And we can also do polynomials. I'll just say polynomials. Polynomials. Mainly trinomials. Because you will hardly have more than that. Trinomials. But if you've got some quartic expression there or quintic expression, you need the long division to assist you. So there's lots of techniques that you can use here. So the last technique that you need is trig ratios. Trig identities. Okay. So all of them. So this is what I call the 3-step approach. Of course, I'm not the champion of it. You will see that there's plenty of people who actually described this before me. I just looked at it my way when I was yourself as a matriculant. So I found these techniques to be very useful. So I do believe they can help you as well. Okay, we will just try and display how this works as we solve this problem. So let's start. Here we've got a half, so there's nothing we can do with that. Can you see now, reduction formulae, BODMAS, BO. The reduction formula here is 90 plus, which is a cofunction of cos. Now the cofunction of cos is sine theta. But this is the second quadrant, cos is negative, so will its co-ratio be? So we've got minus sine theta times, again, this is a cofunction for sine. But now, where is this angle? What is theta minus 90? Now, if you think of your Cartesian plane, there are some shorthand techniques. If you've been following my channel, you will know what this is. So minus 90 is here, it's 270. But now theta is positive, it means we're moving in this direction. So this is simply trying to tell us that this is an angle in the fourth quadrant, okay? So because this would be theta going clockwise, because anti-clockwise, any positive angle in maths is going anti-clockwise, any negative angle is going clockwise. So be very quick to notice these kind of things, because they like to confuse you. So there is our theta there, okay? I don't know why my theta didn't look so good. Either way, so that is the story. So this is an angle in the fourth quadrant, basically. So we can see here that minus sine of this angle is going to be, sine is negative in the fourth quadrant, and so will cos, all right? So this is going to be essentially minus cos theta. The other way to think about it is to say find sine of theta minus 90 degrees is the same as sine of, you factor out a negative, 90 becomes positive, and then theta becomes negative. Now we know that sine of a negative angle is negative sine of 90 degrees minus theta. But now we are looking for the cofunction of sine of 90 minus theta. That would be cos theta. This is suggesting first quadrant, but because of that negative that's dragging, it's going to be minus cos theta. So can you see there's plenty of ways, quick techniques and some long techniques. You choose yours. As long as you know what to do, you just move along and get this right. It's not so difficult after all. So that is what we have on the numerator. So let's look into the denominator. We've got cos of 180 minus theta. So once you see 180, you know that same function, nothing changes. But now the problem is that cos in the second quadrant is negative. So this is minus cos theta, but then it's squared. So we're going to square that bracket. Minus 2. Again, cos of a negative angle. This is an angle in the fourth quadrant when we're going clockwise. So this is theta. So when you're going clockwise, that is minus theta, okay? So of course there's being the axis and the origin there. So essentially cos in the fourth quadrant is positive. So this is going to be minus 2 cos theta. Just leave it like that. Plus, again, we've got a situation here. We've got theta plus 90. So this one is easy because the signs are both positive. So this is not a problem. We know that this is basically an angle in the second quadrant. 90 plus takes us to second quadrant. But cos says now we're going to take the cofunction of it, which is sine. But now in the second quadrant, cos is negative, and so will the co-ratio. But now this is squared. Okay, so can you see, guys, all I have done here is reduction formulae, nothing else. So my BODMAS, I was just on step 1, essentially. So now let's simplify a bit more. So we're going to have here a minus a half of sine theta. Now minus times minus is going to be plus, essentially sine theta cos theta. Okay. Then here we're going to get cos minus cos theta all squared is going to be cos squared theta, that is positive. And then we've got minus 2 cos theta plus this one is going to be sine squared theta. Okay, so now we're taking a bit of shape. So what do we know? What can we do here? We can see, well, in the numerator we can factorize this thing. So this means this step is kicking in. We are here now because we can see there's a common factor, sine theta. So we can just take out sine theta and say, look, if we take out sine theta here, what do we get? Maybe let's take a minus sine theta and see what happens, because we want this sign to come up. So we're going to take a minus sine theta. And then what do we have inside? We're going to get a half minus cos theta. Esan thini ngathi yala sesifikile. Anyway, you know what now, what I'm thinking something here. Let's not do what we did. It's dangerous. It's going to cause us problems. As you can see, we're going to have a half which we don't have here. So let us not do it. Let us not do it. It's going to cause us issues. But there's a step that we can actually employ here. Do you realize here we've got sine, cos, and then there's sine here, right? But now what is a half? If we wanted to express this half as a cos, so this could easily be, yes, but it's not working still. It's still not working. It's still not working. But anyway, let's just continue with our factorization. We will find a way of making it work. Sometimes certain things, the first time they don't look right. This is why you need your RW there. Let's take out a minus sine theta. What we end up with is a half minus cos theta. Okay, because what I was thinking, I was going to say this is cos 60, but cos 60 is not going to help us. Now, here, what do you notice, guys? There's something that is very noticeable here. It is the fact that this guy, cos squared theta plus sine squared theta, that is a square identity. So this one saves the day. That whole shenanigan simplifies to 1 minus 2 cos theta. Alright, so that is what we get on the denominator. Can you see our 3-step approach? We've used every step essentially. But now we can factorize the denominator so that we look exactly like the numerator. Now how do we do this? We know this is going to be minus sine of theta into a half minus cos theta. So this, we come back and say, look, we can pull out a half here. If we pull out a half, things are just going to fall into place. You get me? Yes. Let me see. All I want is to be able to have cos here. So, but now there's a 2. Okay, let's try a quarter. But if we take a quarter, it's not gonna work, is it? Because I was thinking here, we can pull a half here. If we pull a half, oh yeah, it's not gonna work if we pull a half. We need to pull more than a half. Essentially, to get a 1, we need to pull a 2. I think it's best if we pull a 2. So we pull out a 2 as a common factor. I mean, with numbers, you can always play. So now this one leaves us a half minus cos theta. Okay, that was the tricky part, actually. Otherwise, the rest was standard stuff. Now look at what is happening. This bracket takes care of that bracket. Because those are... Now we're back to BODMAS, dividing common factors. Damn. This leaves us a story of minus a half of sine theta. Alright, so that is our answer. At least this is a single trigonometric ratio or expression. Ratio actually. So again, you can check yourself here if you are correct. Just assign a value for theta there. And let's see what do we get. Let's just put a 2. So we've got minus 0,5 into sine of 2. So what I'm getting, when I substitute a 2 for my answer, I get is minus 0,0174. Rounded off to those 4 decimal places. Now I come back here. I will write minus 0,5 into, now we have got cos, so it's going to be into cos of 90 plus 2 because we're putting a 2 in there. But now be very careful, the brackets can overwhelm you here. They can overwhelm you so badly. So here, get rid of one part, and then we're going to say minus sine of 2, right? Into sine of 2 minus 90. Okay. So be careful of brackets, and then I'm sorted with my numerator. Then I'm going to divide this whole thing by cos. Maybe let's just say here, in brackets, cos 180 minus 2. But yeah, guys, be cognizant of time, though. Sometimes time can be a bit of a mess. But now here, you've got to be very careful on the denominator because there's terms, so if you're not careful, you might run into problems. So this is minus 2 cos minus 2 inside. Okay, and then plus, again in bracket, cos 2 plus 90. Okay, that is squared. And then we put the last bracket. So if you don't do this right, you will run into some serious problems. So I'm essentially getting a minus 0,0174 as well. Okay, maybe 5, slightly different, but they're not so different. So I'm getting the same, so I'm quite convinced my reduction is correct. So I can safely move on without fear of being wrong. So I don't know how many marks was allocated for this question, but whatever it is, what I can tell you is this reduction is important, and essentially yeah. So this reduction actually is the one that is important, and this reduction is important. This is important. That is important. And that is important. So already you're getting 5 marks from just doing those reductions. And then this step of factorization is important, and this one is important using the square identities, and the final factorization there might be an extra mark. So how many marks now? We've got 5, 7, 8, and essentially this would be the 9th mark. This could easily be 9 marks, but maybe you may get just 1 mark for factorizations, even though we delayed it in the other step. So perhaps we can say 8 marks at best. You can just say for both factorizations you're getting 1 mark. So essentially 8 marks. Usually this is around the marks you would get for this question. Okay, there was this question 12 also, the Euclidean geometry. So let's have a look at it and see. In the diagram, circle with center O has the diameter AOC. So where is the diameter? AOC. So if that's the diameter, it means this angle subtended by the diameter should be a right angle. That's the angle in the semicircle. Okay, great. It's a very important corollary here. Then of course we are told that O is the center. Okay, now we are told here, and chords AB and BC. Okay, AB and BC. Okay, fine. Chords AD and EC intersect at F. Okay, with OF perpendicular to EC. OF. So can you see this is the line from center, and it's perpendicular to chord. FC. So what does that mean? If this is perpendicular to chord FC, it simply means EF is going to be equal to FC. Line from center perpendicular to chord actually bisects the chord at point F. Okay, all right, okay. So we are told here chords AD and EC intersect at F with OF perpendicular to EC. Okay, that's what we just said. Now AOC, the diameter bisects BCE. So if that is the case, it means this angle here is equal to this angle right there. Because if that is the case, it means those two angles are equal. So this suggests that this arc AE is the same as the arc AB because they are subtending equal chords at circumference of the same circle. All right, not a problem. So now let's try and answer some questions. It says, state all relevant reasons with your statements. Okay, prove that triangle ABC. So we're supposed to compare these two triangles. So the yellow triangle and this blue little triangle there. Obviously, they just told us that this angle BCE is being bisected by AOC, meaning this angle is equal to that angle. That angle is 90 degrees subtended by the diameter. This one is 90 degrees. It was given. Okay, so that means the remaining angles will be equal. So this is so easy. So we'll start by saying in triangle ABC and triangle OFC. Okay, so what can we say here? We will simply say essentially angle, we'll start with the other triangle. We can just say angle B. Angle B is equal to 90 degrees. Right. What is that? This is an angle in the semicircle. Okay, angle in the semicircle. And then we can say also F1 is equal to 90 degrees. Why? That was given. We can say therefore B is equal to F1. H equals 90 degrees. that is essentially what we wanted to say. You can say also, what do we know? We know that angle C2 from the other one is equal to angle C1. We were told that AOC? We were told that AOC bisects ACE. Is it BCE? Bisects BCE. That was given. Okay. Now, what do we know? If we prove two sets, this implies that essentially angle A2 in the other triangle is going to be equal to angle O2 in the other one. These are the remaining angles, okay? Or you can say three angles of a triangle. Therefore, we can safely say ABC is similar to triangle OFC because they are equiangular. Don't forget that reason, it's important. Without that reason, that statement is incomplete, okay? Just think of this is how everything is connected together, its reasons, as you would in algebra when you're performing BODMAS, okay? The order of operations. Okay, let's go on. Next question. So easy 4 marks here. Where do we get this one? From identifying that angle is 90 degrees. This one was given, not a big deal. And then noticing that those angles are going to be equal, essentially, and knowing that these remaining angles are going to be equal. And the last reason with its statement gives us those 4 marks. Next question. Determine the numerical value of BC. Now BC is the side on the other triangle over FC. So FC is also a side on the other triangle. Okay, all right, okay. So let's see, what is BC over FC anyway? BC over FC. Are those sides even related? Now BC is the side opposite angle A2 in this triangle. But angle A2 is equal to angle O2 in the other triangle. The side opposite it is FC. So definitely those ones form a perfect ratio. But now we need to be smart. What is this equal to? Well, I'm going to choose AOC on the other triangle. Why? Because I know AOC is twice OC. This is the radius, this is the diameter. So I can have a nice division so that I can get a numerical ratio there. So I'm going to say AC over. Now AC is opposite the right angle. The right angle is equal to F1. The side opposite that is OC. So that would be OC. Now, these are the proportional sides in similar triangles in A. Sometimes you want to state, why are you saying such things? Where did you get it? Please give us the information because it is very important. Now, we can safely say this is equal to AC. We can decide how we write this one. AC we can express as twice OC. 2 times OC over OC. Now, what is the reason here? We know that the radius is half the diameter. We can say the diameter is twice the radius. It's as simple as that. You can say diameter is equal to 2 times the radius. So why do we need to suffer? We don't. So this guy takes care of that guy. So this one essentially, I don't know what I'm doing there. This is going to be equal to 2 over 1. Okay? Therefore, make the conclusion, guys. Okay, I'm running out of space. Therefore, we know that BC is to FC is going to be equal to 2 is to 1. Please always attempt to present the answer according to the way it was asked, because if you start answering questions your own way, it's okay, but the conclusion has to be something similar, if not in the manner in which the question was posed. Otherwise, you may find yourself losing you would find yourself losing marks unnecessarily. So, I don't know how many marks here this is, but most likely, sabu 2 marks anyana, sabu something. This one is definitely a mark. Knowing how to find the proportional sides is important. And essentially, this statement right here is also pretty important. The substitutions and the justification and the final answer. Maybe 3 marks at the very least. Okay, so let's move on. Last question. It says, now hence prove that AC over 2 all squared. So where is AC? So there is AC, the diameter, is equal to, minus AB. Now there is AB all squared over 2 is that one, is equal to DF. So where is DF? So always inspect these things, guys. You will get clues. Where is DF? Now let's find DF. Now DF is this portion here. Now DF is here. Okay? Over FA. Times FA. Where is FA? So FA is also on this part right here. So what does this mean? Okay, alright, okay. Now, what this simply means is to justify why this DF or FD is equal to something. Okay, but now we need to be smart about our business. Because this side belongs to this triangle there. But what I'm seeing here, guys, how many marks is this thing? I don't know, but I think this one had a bit of marks in it. But what I'm thinking, we need to prove a similarity here of yet another bunch of triangles. I'll just highlight them. Okay, so what I'm seeing is that we need to compare these two triangles, this light blue one and this slightly deeper blue. We need to compare those triangles, in fact, for similarity, because that's the only way I can find us, working in this manner. So you see, inspecting some things helps a lot in terms of identifying the cause of action that is necessary. Now look, this angle is going to be equal to that angle. Why? These are angles in the same segment subtended by arc DC. Likewise, these ones are going to be equal as well. Why? Because these are also angles in the same segment subtended by arc EA. And what do you notice again? These are vertically opposite angles. This one here and this one here. So those are vertically opposite angles, right? Because those lines are cutting there. So essentially those triangles are similar. So usually they are not going to ask you things you will not be able to see, but you will see there's a lot of craziness coming in here, because you see now there's this divided by 2, which we will deal with later. But if we've got a square on AC and AB, and then we've got a sine, there is Pythagoras included, and we can see here this is a right angled triangle. If we've got that side and this side, it means we looked for this one. As to why, I will find out. Okay, we will find out a bit later Why is that? Okay, so why did we have to find that side? We will find out why, or what is the importance of that side. This one is a very silly question, but let's start. We can just simply say here, in triangle, let's call it, let's just call it EFD. I don't really care for the naming because it does not affect anything that I'm going to do. And triangle, this one is AFC. Because I know if I have to do the ratios, for me, I just take the sides opposite equal angles. Those are the sides in proportion, so it's no trouble at all to cram that thing that if it is placed like this, then this is what it means. It's okay. You can provide an easy way out, but what if you're getting caught out at some point? Because they may do it deliberately because they know you'll expect that. But of course, it's something to think about, but it's not something to just hold on to, okay? Be very careful. Maths is dynamic, guys. They will always find a way of tricking you while they are also maintaining the standards. So be flexible. Don't be stiff. That's the only way you can survive. Okay, let's start. Now we're starting with triangle EFD. What is that angle there? We're going to say that angle E, because there's no other angle there, so it's going to be angle E. So we're going to say, well, angle E is equal to angle A1 on the other triangle. What is that? These are angles in the same segment subtended by arc, because there's no chord here, arc DC or CD. Right. Go also, we know for a fact that angle D, because D is standalone there, is equal to angle C1 on the other one. Again, these are angles in the same segment subtended by arc. This time is AE. Okay, that's what we look basic bag will be for no reason. Okay, arc AE, you're getting it right? Right, so if we prove two sets of angles to be equal, we literally do not need to be justifying those ones, but in any case, let's just do it. EFD, let's just do it. We can say in fact here, let's just use some nice words here and say likewise, most, because it's the same reason. Then we can say also, now I wanted to say that one, I know that EFD is equal to AFC. Now these are vertically opposite angles. Vertically opposite angles, so that's a grade 9 issue. Okay, now that we've proven these ones, you can say therefore triangle EFD is similar to triangle AFC. This is because they are equiangular. So now we want to extract some stuff. what is the stuff that we want to extract? It is stuff like this. Let me try to see what is the story now. How do I get to this? Obviously, that ratio of BC over FC has something to do with this, because I'm sure there's something we're going to need here, but let's just plan it just right. BC over FC. BC over FC is equal to, all right. Now what do we do ke ngoku? Yeah, ingathi saba sisenjeni ke ngoku, sesiyifumene into ebesiyifuna but ayifiki ngale ndlela esiyilindele ngayo, because my question is why is BC ungenaphi kwezi triangles ezimbini? Well, uside AC nguye lo ozawuzisa BC, right? Because we know Pythagoras says the hypotenuse side is going to be the sum of those two sides. So we can first use this side, and then instead of this side, we substitute with that one. Yeah, it looks like it's going to work, although I'm not sure how, but let's start here. What are the sides that we're interested in? It's going to be this F or ED. Let's just use ED. Do we have ED here? No, we don't have ED. Okay, all right, okay. I'm trying to see rough word, but all we know is that DF or FA must be there. FA and DF must be there. So we don't have EF, we don't have FC. Okay, all right, okay. Let's see, that angle is equal to that. We've got FD here. Yeah, that's gonna work. So masqale ngala FD. Let's start with FD, since FD is there. So we can say this implies that FD, or did they write DF? Let's write DF. This means DF over, now DF on this triangle is opposite that angle E. Angle E is equal to A, and the side opposite A is FC. So we've got FC there. So we've got FC. Okay. Must be equal to, what must we find? We can see there that there's an FA also, and FA is on the other triangle, but this is opposite this angle here. That angle is equal to that, and then that side is equal to EF. So we're going to write EF over, now EF belongs on this triangle, opposite D, that is equal to that, and then it gives us FA. Alright, so that would be FA. So this thing is almost there. So this is now proportional sides in similar triangles. Okay, we just proved them here. So still the same question. Okay, so what do we know, guys? We know that this dude here, this dude EF is equal to, EF is equal to FC. Line from center perpendicular to the chord bisects the chord. So this is where that theorem is going to come in. So we will start doing some gymnastics now. We're going to say, okay, all right, okay. this seems like we have something very interesting indeed. Let's just cross multiply before we start talking that stuff that we want to talk. So we're going to say, okay, all right, okay. We can just try to cross multiply here. We're going to get df times fa, okay? But they decided to start with this one anyway. So we're going to say here fc, fc times ef is going to be equal to df times fa. Okay, how did they write it? They put a multiplication. So always, guys, pay attention to the notation dictated by the question. You distort it at your own parish. Okay. Now, what do we know? We have a story to tell that essentially, however, it says it's however, we know that EF is equal to FC. Okay. Why do we know this? Because of the line from center perpendicular to chord bisects chord. Now, what were we given? We were given here that OF is perpendicular to EC. So always try to be as comprehensive as you can. There's no need for the reasons to be actually short. As long as your argument is making sense, you should be forgiven. All right, so now this implies instead of FC, we can write, let's see, where is FC anyway? Yeah, we can write FC twice instead, because FC is what we know from above. So we can just simply say now, therefore, FC multiplied by FC is equal to DF multiplied by FA. So the right-hand side is already the way we want it, so we're not going to bother with that, which also implies that FC squared is equal to DF times FA. Okay, good. So now, what is FC squared? Holy cross. If you look at FC squared, it is essentially OC squared minus OF squared. All right. Now I'm trying to think what would be, how do I get AC here? How do I get AB there? Because those things have something to do with this thing here. Izosebenza. Let's start with OC squared. We can say now 8 so thini ke ngoku masike sithi ke ngoku amagama aphelile ke ngoku, or however, or also, or likewise sibenzile. So what do we say? We can say we noted. Maybe we can still say, this is an argument. We can say, but what do we know, Bafwethu? We know that OC squared, or this FC squared, let's just say FC squared, is going to be equal to OC squared. You know what I'm thinking now? Let's not even use buts here. Let's just run into it. Instead of writing this, we're going to say OC squared minus essentially OF squared. OF squared is equal to DF times FA. What do I know? I know this is from Pythagoras. Pythagoras theorem in triangle OFC. I'm trying to show that instead of expressing this, remember, we know that OC squared would have been FC squared plus OF squared, isn't it? So here I'm trying to isolate FC squared, so you would transpose this to that side. So now FC squared would give us OC squared minus OF squared, so which is what I'm substituting there. At some point you need to be brave and not be too scared to just write certain things. When you've said a lot already, there's no reason to suffer a little bit more. You can just try and be very smart about your work. Now, why are we doing all of this? We are doing all of this because we know that but do I really need the Pythagoras theorem here? Because I'm trying to think now, I've introduced OF, which I don't need. I really don't need OF here. Now I'm trying to look at this ratio that we got here. This ratio that we got, we actually should have used it rather than this Pythagorean theorem here. It doesn't help us at all. Let's just not do it. Let's just not do it. It's dangerous. But I know Pythagoras is coming, but maybe not in the way I'm saying it. So let's just try again, okay? Sometimes it's a trial and error, folks. Don't think you're just going to know how to go about it. We have proven, though, that actually FC, if you look at this ratio right here, BC over FC, look at that, BC over FC, we found that this is 2 over 1. So imagine if we want to find out what is FC, you can just flip this thing around. FC over BC is going to be 1 over 2. Just transpose that. It means FC is going to be BC over 2. Can you see? So this is what we need. So instead of writing all of the shenanigans, we just substitute there. Nice and easy, this story. Okay. Now let's see, how do we state this? We can say, but we know that BC over FC gave us 2:1. Again, this is what we proved above. So now when we do cross multiplications here, this multiplies there, this multiplies there, we make FC the subject of the formula. This implies that FC is going to be equal to BC over 2. Which also implies that instead of FC now we're going to write BC over 2, and then we're squaring that business because FC is squared. Yeah, now this is going to be DF times FA. Okay, now we know why BC came in here. Because can you see BC is this part. Now in this triangle we use Pythagoras. So we can say now, hey, however, in triangle ABC, this question was a killer. ABC, what do we see there? We know without a shadow of a doubt that essentially BC squared is equal to, now we want to substitute, it's going to be the square on AC, right? So it's going to be AC squared minus AB squared, right, from Pythagoras, minus AB squared. Now this is from Pythagoras theorem. Okay, easy. So now this is the same as BC squared, right? Right. But now we're going to play it just right. We're going to play it just right. This then implies that instead of writing BC, because I mean, if you simplify this thing, it's going to be BC squared over 4, which is okay. I'm trying to think now, what must I do here? Because I've got to separate these terms. BC basically ikhona ingxakana ke ngoku sayibeka kanjani lento yona beseyizile, but the problem yam is that kunalo 4 ozosimosha apha. If we square this iyasimosha, yabo? Yeah, this implies, okay, ndiyacinga ke ngoku ingxaki zethu zifuna ukwanda, you know. Our problems are trying to become many now. How do we link this? Yo, bafowethu, the question ivele yabande kakhulu nayo. Ayayay. Yo, kuzaphela 2 hours ndenza lento. This is nonsense. This is not right, man. This is dangerous. This is dangerous. Ayayayay. Jonga sesifikile bafowethu, but ngoku ayifuna ukudibana because yabona AC nanku sinayo, nankana laa mntu sinayo, but u4 lona sizamthini. Okay, masiyenze kanje lento ukuze silungelwe, masiyisolve la situation here. Masike sithi kuqala imaka kancinci wena soncane ngoba uzosifaka engxakini. Khawehlike, khawehlele ezantsi kancinci. Nansi into efanele siyilungise apha. UBC squared izoba ngubani? BC squared over 4, okay, is equal to DF times FA, okay? So now we can safely do this substitution. UBC wethu uzoba ngubani? ngu-AC squared minus AB squared, all of that over 4, is equal to DF times FA, okay? Now we can say arithmetic, we can split this as AC squared over 4 minus AB squared over 4 is equal to DF times FA, okay? All right, okay, now we can later do the things. We can take out the square, we get AC over 2, then we put the square outside using exponential rules. Yeah, this question was a naughty question, I'm telling you. Over superb. Over 2 all squared is equal to DF times FA. Yeah, definitely guys, this one was a super higher grade question. It's not just a higher grade question, it's a super higher grade question. So you get these kinds of questions. But if you know maths and you've been learning from the best, hey, shiva sediziqalela apho. Yo, ndiyazifonela ngoku. Abantu abazifonela abafuni iketana. But yeah, bafethu, if you've been learning maths from my channel, I'm telling you, this should not be something that makes you cry. It should be something that makes you smile, because you know that you've got a challenge to handle. And then from this challenge, you just have to, you know, do your best. And sometimes your best will always guide you that, okay, you are in the right path. As you can see, I get stuck along the way. But because the maths is there, So every time you get stuck, don't panic. Just think, what can you do now? Because you're just there and you can see the answer, but you needed one little step, just to play around the maths here a little bit. So guys, I don't know how many marks this question was worth, because it was wow. It was wow. But what I can say here, minimum, I would give a mark for proving that similarity, and maybe for these two statements that have the same reason, I give you 1 mark. And the remaining angles are automatic, So essentially, at best, 2 marks for proving that similarity. And then a 3rd mark for using the proportionality here, okay? And then we just go on and do our things. And then, of course, this statement and reason is so important. So how many marks now? 1, 2, 3, 4. And then, essentially, to get here, that's the 5th mark, 6th mark, and this would be the 7th mark, okay? Yeah. This is the 7th mark. And then here, I would give a mark for this application of Pythagoras there, and say 8th mark, and maybe 9th mark. The answer is already given, but I guess the gymnastics were quite critical. It is not just as easy as it was given. To get to it was a bit of a situation. So probably 9 marks for this question. Alright guys, I hope you enjoyed the video and that you will learn something. Please watch it as long as it looks and try to follow it. And after seeing this solution, sit back and think of another way you could have done this. This is how you develop the skills to not panic when you meet these questions in the finals. Especially if you're a grade 11, when you start being taught this theorem, please come back to this video and subscribe to my channel so that you can come back to this video and see these kinds of questions and see exactly what are the pointers to which path must you take to get to the answer, or at least get closer to the answer, and then make a few adjustments, some new gymnastics or some maneuvers that will take you right into the answer. But it simply means your maths needs to be solid. If your maths is still shaky, you will never solve problems like this. But if you sort your maths, your arithmetic, your algebra, trigonometry, your Euclidean geometry in terms of basics, of course, I'm not talking the advanced stuff. If those are in order, I'm telling you, to apply them, it's just so sweet and easy. Yes, at times you get frustrated. At times you feel like you're not going anywhere. At times you feel like you're wasting your time because challenging questions keep coming up all the time. But remember, the more challenging questions you end up solving or end up understanding, the easier it gets to face a new challenge all anew and get it right. Okay guys, this video was longer than I planned, but either way, I'm sure you learned something. And if you wrote this paper, you probably are going to see exactly. This was the Brock Lesnar, the beast, okay? The beast, devouring a student who's attempting to get a distinction and essentially preventing that from happening. But a good student would know that if they've been watching my channel, obviously, because you can see for yourself as well. The way I present my work is different, although not too different, but it's slightly different from how others do it. So in a way, it's a strategy I have learned and developed to make sure that even if you're not so sure, you can get there and very close to the answer. Because the standard means are never gonna take you anywhere. You will get stuck and then you cry. But you will learn a lot from the others in many different ways that they teach, and also in many ways that they have experience with these questions. They're not so common, that it's not so common that you come across difficult questions like this. But you get around them sometimes by putting all those basics together. So yeah, in essence, this channel is not unique, so don't get stuck in it. Please explore other channels. There's so many good channels, there's so many good people out there, and do not shut yourself into this one. But it is best if you subscribe so that you don't miss out on what is going on in this channel, and subscribe to these other channels as well so that you don't miss out on what is going on in there as well. Then you can put it all together and you will be very happy with yourself. Remember, this thing is free of charge, guys. You just subscribe so that you stay abreast of all the activities in each channel, because all these activities are geared towards helping you, and that's all. So there's nothing you're being asked except just hit that subscribe button, hit the notification bell, so that even if you missed the post because we're busy elsewhere, your notifications are going to let you know that you missed something. Then you go and look at it at your own time, because if you're subscribed, you can find every single video in the channel without difficulty. But if you're not subscribed, you will struggle, because you will only see the popular videos posted in channels, and at times you may not get to the one that actually may transform you. Remember, sometimes you're only transformed by a single word in a very long video sometimes, or just a single question in a very complicated video. So if you miss out, you are more likely never to get that on time, and you'll regret, because when you look back, you'll be like, where this thing was there, and I was there too, but I was not aware. So be careful, guys. Don't waste your time. Education is essentially free nowadays. You're just paying for formalities, but the quality is actually more freer than the one that you actually pay for. Anyway, guys, let's not try to be silly now and start saying things that we're going to regret and have to be sorry about. Forget my rambles. What is this? My ramblings or my babbling. I'm always the guy who just talks more than I'm supposed to. So forget the nonsense, but the science, I think it's clear. All right, guys, enough. Goodbye and good luck.